So in our first module, we're going to continue a basic review of operating system essentials. It's important for you to understand what an operating system is, what it does, and what its primary components are. So the intent of our first module is to provide an overview, just so you're as familiar with operating systems, and that becomes the springboard for what we cover in the remaining modules, which have to do with deployment. And that includes initial configuration, well, initial selection of different operating systems, and then configuration and setup and maintenance and troubleshooting, and then upgrades from there. So deployment covers a broad range of topics. And welcome, James. Good afternoon. Good afternoon, James. He may still be, your microphone is muted. Do you have good audio on your side, James? You have good audio, right, Melrain?
Hello? Yeah.
Okay, yeah, James, you're there. Okay, good. All right. So
sorry, I'm on campus right now, so there's a lot of noise.
Yes, I understand. So along with our review of content about operating system essential concepts, what it is, what it does, and the primary components, we wanted to take a moment to walk through the first round of assignments. And I can extend this deadline until tonight, 11:59 p.m., but through the end of this week, if you haven't responded yet to this option for additional credit, a textbook for the course is required, but it's an option to post proof that you have obtained a legitimate copy by rental or by ownership of one version or another, one format or another. So we have electronic versions, and then there are other versions. We also want to call attention to this one. So essentially, when you navigate through the My Campus portal, you can find a section called Microsoft Software Downloads. You click Sign In. I'm going to walk through that in just a moment, but what we want you to do is to upload a text file with your activation keys for Server 2022 Data Center Edition and Windows Server 2022 Standard Edition, because we'll be using those licenses to stand up the virtual systems that you'll use for activities and solutions in the course. And then we'll take a moment to review in greater detail on Friday. So Friday is an important day. 2 p.m. Friday, we're going to start promptly and walk through the steps that you need to follow in order to complete each of the 5 criteria that are listed here, each one worth a point. And you'll be using the virtual system online. That is why your license keys are important now, because in order to set the stage for this here, we need to validate an installation in the platform that we're running. So by navigating the My Campus portal, let's walk through that together. When you clear the login for the My Campus portal, you'll see a screen like this. And you'll walk down to the Microsoft Software Download option. And when you click Sign In, it may prompt you for your email address. If that happens, you need to enter your student email address from UVI. And that will bring up the login portal for My Campus. I've already done that, which is why it's giving me a chance to pick an account to log in with. And I also have a separate Office 365 subscription besides the one that I use on campus. So each of you have an Office 365 subscription, and this is part of the credential and accountability that they use for the licensing. So when you click that, it's going to ask you if you should stay signed in. You always want to answer, don't show this again, and no. That's because the passwords are stored in the cache inside the browser and other settings. And if your password changes, there can be lags between the updates for the stored password. There have also been recent updates and notifications about password managers that have been hacked. So this is one of those things that you want to be aware of. In the Microsoft Azure Education portal, you're going to click Software, and then you're going to select, after you scroll down, you're going to find the two options for Windows Server 2022. The first one for Data Center and the second one for Standard. Now, I already have the install media, and we'll be using the install media for each of the students to build out the virtual machines that you'll be connecting with in the cloud. If you scroll down in the pane that shows on the right, the window pane that shows on the right, there's an option to view the key. Now, when I click this, my key shows up. And one of the things about operating system deployment is that licenses matter. So if I post this video out online, and it's a YouTube video, and I click View Key, my specific key for the UVI access I have, which differs from your specific key, the activation key, if that's displayed in a YouTube video, some of those YouTube videos become very popular very quickly. And what happens is that people download the install media from a variety of sources and repositories and mirrors, as they're sometimes called. And if they have a key, they can set it up and then activate it. And so that becomes a problem. What we're saying is that part of the operating system deployment interest includes the license dynamic. You have open source operating systems like Linux that have it's an open source, it's like an open license. But there are restrictions to the license. So even though it's free for use, there are constraints on it. For example, you can't take a distribution of Linux with the GNU license, accept it, make a few modest graphical changes to it, and then sell it as your own. It has to remain free to the open public. So that's one of the constraints. So even though you're agreeing to using a free operating system, there are still stipulations that have to be honored with a license. In any case, when you click View Key, there's another option down here that'll appear that allows you to copy the key. And you're going to open a notepad and paste that key into here. And on the line below, you're going to label it with Windows Server 2022 Data Center, right? So I know which key is which. And you'll skip a couple of lines. You'll repeat the same process for the standard edition. And when you save this text file, you're going to save as with your particular, so if I go in here, now I'll go into assignments. One, I'll save this as my first initial and last name, right? And then basically that's the text file that I'm going to upload for my submission for the assignment. Are there any questions about the 1.2 assignment?
Nope, pretty straightforward.
Okay. I'll post this recording as soon as we finish the class. So basically, if you forget the steps involved, you can reference the video. I'm going to go ahead and clear this. And the ability to use remote desktop. If you have a Windows 11 machine, Microsoft Remote Desktop is actually included. If you just search for it, even though it's a home edition. If you have a Mac, there is an option to install Microsoft Remote Desktop through the App Store or as part of Office 365 when you install Office 365. It's inside the Office Tools folder. This is one thing that's, well, it's the first step of the solution, right? And this is something you can do today or between now and the start of class on Friday. And then basically in the meantime, I'm going to be working like one of Santa's elves in the background, and I'm going to be setting up access between now and Friday so that when you send me emails saying, hey, I need my login and password, I've been replying in recent, well, at least today I've been saying, well, we'll be reviewing that on Friday and I'll send that later. So that's the first response you get back. But one of our students has already gone ahead and logged that request, which is really encouraging. When you get the information back, you need to show it on your screen. So you'll have a JPEG. So your login and password will not be sent in the clear. What am I saying? When I reply to your email, all right, so let's say I have a new email here. Let's say I respond to your request and I reply back. If I put in, here is your login account and temporary password. I misspelled that. As soon as I send that email, email travels in the clear over the open internet. I don't know if you're aware of this, but it's a terrible idea to have login information sent by text or by email, because that information travels across the public network in the open, in clear text. Hello. So what's the workaround? I'm going to display your login and your password, your temporary password, in a separate window, probably a paint window. And what I'm going to do, well, let me do that. Let me update my paint while I'm in here. So I'm going to open up the paint window. Then I'll capture my screen, and then I'll crop or cut a small image and save it as a JPEG. And I'm gonna send you a reply that basically says, per your request. I'm not gonna put in the subject line, ooh, here is your login and password. Can anyone guess why I'm not gonna respond by announcing that here is your account and password?
I guess security purposes, reasons?
For security purposes or reasons is correct. When this travels in the open in clear text across the internet, there are bad people in the public network that often capture transmitted traffic. It's called sniffing on a network. And then they do a search for strings like password, login, stuff like that. And up pops your handy little email, and away you go. And then all sorts of havoc starts to happen at that point. So I want you to be aware of what to look for. I will reply back to you in a totally separate email, because if you follow the steps, you may actually put in the subject line, hey, I'm sending this email to request what? My login and password. If I reply back to that, the subject is still in there unless I change it. but then it's still embedded in the body of the email. Simply put, I'm going to send a separate email that says, you know, per your previous request, and then I'm going to have an attached JPEG file. You're going to open that up by double clicking on it, and it'll open in a graphic viewer, either Paint or what are the options here? Like there's all sorts of graphic viewers, but basically it'll prompt you and ask you how do you want to open this graphic? And as soon as it's on the screen, then what you can do is view it on the screen, capture that, and upload that for the second point of your solution. All right. Now, why am I asking you to capture it on your screen? Well, that's one of the ways I know it's you, because there are telltale signs. And it's also important for security reasons to handle the process in that manner, right? Now, you're not sending that back to me in email and saying, here's the second part of my solution. No, you're uploading it as one of the 5 artifacts that you upload for your Module 1 solution, okay? You'll use those login and credentials to get on your virtual system, and then you'll finish everything from there, okay? And we'll cover the rest of the tasks that you perform on your remote system on Friday. And then if you have everybody's going to try their remote login on Friday, which is why everyone should be here on time at 2 p.m. on Friday. Because if you run into a snag, we're going to resolve the snag. I'm going to provide support in real time during the class so that as the weekend starts, we will know that you can do the rest of what you need to do to get in there, okay? Everybody good? It's actually pretty cool. This is the first time we've actually used our virtual systems online for this class, and I am completely jazzed. You're going to use it right away to set up a network share and then map to it across the local network. So you'll get a taste of some things you can do to like automate and set up servers for resources, set up servers for the updates that have to be loaded, or for, you know, sharing data. You'll get a flavor for how that process works. All right. In our class last week, we basically covered the primary purpose of an operating system, and we talked about how there are 2 roles that an operating system performs. And when those roles are being fulfilled, there are actually 3 primary or main functions that each operating system must provide in order to be an actual functional working operating system. And we actually showed you some publisher slides, I think. There is a separate student learning objective that we want to take a moment to capture here. There's a pretty famous author that you're going to have the chance to engage in some of your courses at our university. The primary textbook for CSC 110 and CSC 117, 118, and 242, the Java series, Tony Gaddis is a famous author. And so he has a series called Getting Started with Python, Getting Started with Programming, Getting Started with Java. And Tony spoke with authority by saying, you know, an operating system and its components, you really got to broaden your sense of what an operating system is, because when you're talking about where it operates, it's active on what we would refer to as a platform. There's hardware And it might be part of a bigger data center with lots of servers and a network. So the word platform is kind of depends on context, right? But when you look at Tony Gaddis's sensibilities about what an operating system is, he defines three primary components. There's the operating system itself, right? And then there is a complementary set or suite of system utilities. And we kind of take these for granted. Now, what do we mean? Has anyone ever seen Task Manager here? Did everybody see my system?
Yep.
Great. So Task Manager would be a great example of an OS utility, right? Computer management is another example. So if I click here, or if I start search and I start typing computer management, there is a computer management. It's called a Microsoft Management Console, or MMC. And this is a very old, very time-honored operating system utility that allows us to, troubleshoot problems with the digital devices that are connected, to manage our disks, or to configure them for better security. We can basically start and stop services that are running. There's a log of system events, including the Windows log. There's a security log, right? Within there, application security, setup log, system log. These are all resources that have come to be expected with most operating systems. Now, there are versions of operating systems that don't have any of that. And in particular, Linux server operating systems tend to be very Spartan. Just the operating system. If you want utilities, in fact, there's one version of Linux that has a very small footprint, and it'll run on almost anything. There's several, but the one that's my favorite is called BSD, or Debian. It's Debian. BSD is a slightly older related concept. Debian is something you can put on only a small part of a CD. So with just a couple of 100 megabytes, you can load the whole operating system. There's no GUI. There's no graphical user interface. You have to know the commands to install a graphical user interface. And there's no tools. If you want to be able to do things like manage disks, you have to download those additional utilities. So those are extreme examples of exceptions, but I wanted you to know there are exceptions to this general rule. The other thing that Tony Gaddis, go ahead, was there a question?
Yeah, I was just gonna ask. So like, is that just so that the user or programmer, computer engineer, or whatever has more, I guess they're able to customize what they want more? Is that the reason why they do that?
Yes, that's a great question. And the short answer is yes. In the world of Linux, right? So we talked about Debian download. Debian is so important in the world of Linux. The kernel of the Debian operating system is used to build other distributions. So other flavors of Linux are called distributions. And you might have heard of the term Kali, or Ubuntu, or Mint. Mint is a very popular one, right? And if you download Debian and you download a server version, another version of a very stripped down Linux is CentOS. And it's, at one time, there was a huge number of websites that were built on CentOS. You may have heard of Red Hat. And Red Hat Linux offers this. They take older versions of Red Hat and they release them as open source so that the world can take advantage of their older versions of Red Hat. People who pay for support, and we'll talk about the differences of licensing in just a minute. People who pay for support with Red Hat get to use Red Hat, but if you don't need support and you can handle the basics, you can download the kernel of their operating system free. And to answer your question, Milrain, you can recompile, you can download the source code for some of the, well, actually most of them. It's readily available. You can download the source code and then you can update low-level components of the operating system kernel, in particular hardware drivers and such. And that's called tuning your operating system. So if you've ever wondered how new companies can support thousands of users on a budget, this is one way they do it. They get free operating system licensed distributions, then they fine-tune them to do what? Only website. Nobody logs in to check their email. Nobody browses the web on the side. It's a host for a web server, and that's it. Web server software. Does that answer your question?
Oh, yeah, definitely. Definitely.
Okay. Now, Tony Gaddis asserts that there's a third piece of all operating systems that ultimately come down to software development tools. And that's because an operating system has what's known as an application programming interface. When people are developing software for a given operating system, they're using a function in software called a system call. And there's a standard library of features and functionality modules. And those APIs, application programming interfaces, are the hooks on the back end of the operating system for which certain developers provide programming tools. So a good example of a suite of programming tools might be something like, has anyone ever heard of JetBrains?
Yes, that's where you get
Yeah.
IntelliJ, PyCharm,
Yeah,
other
yeah,
IDEs.
exactly. And those IDEs, right? You see the IDE embedded in this, right? So they've turned IDE into IDEA, right? Really catchy. It's pretty catchy marketing when you think about it. Those integrated development environments are explicitly designed to tap into the component of operating systems we call the APIs, right? OS API. And so there's an application programming interface for the devices, for access to the digital devices in a system, and for access to the graphical user interface, right? So the GUI. So the front end, the graphical front end for the user, something we'd call GUI, right? There's an API for that. There's also an API for access to things like the terminal, the CLI environment, which is often referred to as the command line interface. When you see command line interface, that's a reference to a command prompt. And you notice I'm running it as administrator, right? So you see the word administrator here. In Windows, the command prompt or the PowerShell prompt is so PowerShell is a replacement, and it's designed to act more like the terminal environment in Linux. So there's a lot of envy going on between free Linux and commercial Windows. And lately, a lot of people have been adopting free Linux because there's more you can do from the terminal. And Microsoft's answer to that is, hold your phone. We now have an enhanced, improved command line interface through the PowerShell environment. And it's the command line on steroids, right? And you notice I did not launch this with administrative privileges. So there would be limits to the PowerShell commands. Some would say, well, you don't have permission to do this. In which case I would simply restart this and and run it as an administrator. Does everybody see that? So now I'm executing PowerShell commands as an administrator of the operating system. So those are things we're going to explore in greater detail in our future modules. But one of the things I wanted you to understand was this expanded notion of what an operating system is and what its primary components are. We learned in our last class that there are primary functions. Can anyone remember any of the primary functions from our previous class?
Wasn't here for the previous class, so I don't have the answer. Sorry.
Okay, well, this is kind of a review, right? So there's a reference, there's a link to a reference in your study guide and in Blackboard to an author, world-renowned author, who decided to give his operating system, and he's a computer engineer, so he's part of the computer engineering department at the University of Wisconsin at Madison, which holds the coveted distinction of having one of the best engineering programs in the world. And so he created a textbook on operating system principles in 3 easy pieces. And he talks about virtualization, concurrency, and persistence. Those are the 3 functions that we covered. So virtualization allows all the different hardware platforms to operate with just one operating system and just one application. I mean, otherwise you'd have to recompile the kernel of an operating system every time when someone changes the brand or the model of their PC or their laptop. It gets old, we'd never have a life and nobody would procreate. Concurrency is all about doing things multiple things at once, multitasking. And persistence has to do with the ability to store the results in non-volatile memory in one storage media or another. If an operating system doesn't provide the hooks for that, if they don't provide a file system in common terms, then it's not an operating system. I mean, you can turn something on and use it, but then when you turn it off, you lose all the work you did. There are 2 roles that an operating system must fulfill, and those 2 roles are often confused with the 3 functions. So the roles: resource management and abstraction. That's really what an operating system does. It creates a virtual, an abstraction of the hardware that all of the applications can use. So it takes the network card, the processor, the memory modules, and it creates an abstract version of that in memory inside the memory address range. And your applications actually use that instead of using the memory modules directly. What am I saying? Well, if I go to computer management and I look in my device manager, and let's say I look at have any of you seen this before? I look at my network adapters, right? Now let's look at the Wi-Fi adapter I have right now. These are abstractions or virtual representations. So in order to create an abstraction of my Wi-Fi card, which for this Asus laptop is different from the Wi-Fi card on your laptop and the Wi-Fi card that might be on your gaming platform, right? We have to create this abstraction, and we do that with virtualization. So the function that comes into play that allows that to happen, so if you look here at resources, can everybody see this?
Yes.
This is where the abstract version or virtualized version the virtual representation of my Wi-Fi card lives. As it's operating, there's a virtual creation of my Wi-Fi card running in RAM right now. And that's how my Windows 11 operating system is able to do the same thing with that Wi-Fi card that it does with your different brand and version and model of your Wi-Fi card versus the different brand and model of the Wi-Fi interface in your smartphone, right? So when you think about it, operating systems do some heavy lifting that way. And it's a really important, it's a really a big deal. Any questions about what we just reviewed? So if you look at the video from last week that we captured, and we didn't have class on Friday, but if you look in here, in resources, in session recordings, here's the session that we started last Wednesday, and then we confirmed that we're meeting on Monday, Wednesday, Friday at 2 p.m. And then Friday, I had some registration support. I had to cancel everything for the afternoon because we still had a lot of students that hadn't registered for spring. So I sent a notice out that said, so sorry, that's why you don't see that here. As soon as we finish here, I'll put the recording for today and it'll be at the top of the list. So in descending chronological order, the most recent recordings will be right near the top. Okay, so in case you missed our session, our first session, there it is. You can kind of watch it. And some of those things we just talked about here, concurrency, persistence, virtualization, we covered then. It's important to cover this more than once and to come at it from different angles and on different occasions, because essentially some of these concepts are pretty new to people, and you have to hear it more than once, and you have to review the ideas, the related ideas in different ways. So in any case, yeah, here we have an explanation of how this persistence works, non-volatile RAM. One of the important aspects, if you've taken CSC 241 computer architecture, you've already seen this, but one thing we want to understand, operating systems sit on top of the hardware, and every system has primary hardware components that can be represented by von Neumann's model. So, and there is this thing called I call it the waltz, the CPU waltz, but the computer engineer from University of Wisconsin said that and this is in every textbook worldwide, a CPU fetches data and instructions, then it decodes the instructions, and then it executes them. So it's a three-step process: fetch, decode, execute, fetch, decode, execute, fetch, decode, execute. And that's really what happens inside the kernel of an operating system. On a very rudimentary level, that's what happens, and it engages the CPU to do that, or actually a virtual representation of the CPU. My laptop in particular has certain physical cores. Everybody with me?
Yeah.
So over the Christmas holidays, I replaced my laptop, and my family all banded together and got me a really nice Asus gaming laptop. And the CPU is pretty beefy, but basically there are physical cores in the CPU of my laptop, 10 of them. Some of them are virtualized or hyper-threaded so that the count is actually doubled. So I have 16 virtual CPUs on this laptop. Now, your mileage may vary. I was using a laptop in my last semester that had 4 logical processors and only 2 physical processors. But the important point is to understand the hardware OS relationship and how those map to each other. And then to close out this session, the one thing that we want to call out is that all of this changes so dramatically. There's a gentleman that started Intel. Has anyone ever heard of Intel before?
Yeah.
Absolutely. So his name was Moore, and he basically said, I was going to say, I hope this works. Every 18 months to 2 years, the capacity of a CPU is going to double. And he said that a long time ago in 1975. And since that time, that law has held true, where computer engineers have been able to innovate processor design so dramatically and so rapidly that the capacity of computer chips has doubled every 18 months to 2 years, which means that our hardware is way ahead of the operating system and software. And that's just one important thing to remember. But when you're dealing with new CPUs and new operating systems, the whole magic of an operating system can be captured in one thing, right? An operating system provides the ability to continue to use the graphic interface and the applications that you know and love, even though the hardware is changing up so fast, even though the operating systems are being updated so fast. Because of that virtualization, you know, we would have to basically come out with new versions of operating systems and applications every 2 years, every 18 months to 2 years, just to keep up with the new hardware, right? And that is so profound when you think about it. Without this innovation, the computer world that we know and use without any thought whatsoever, getting on the internet, using all our devices, none of that would be possible, right? So here I explain a little more about each of those concepts. And I think what we'll do, so this diagram is a crude drawing, but basically when you look at the von Neumann diagram, virtualization involves every one of these components of a hardware system, a computer system. The memory zone, the CPU zone, they're referred to by zones. And the input-output zone, that's the hard disk, right? Concurrence involves memory and processor more than the other zones. And persistence involves this, mostly input-output, right? So on Friday, we're going to get into the 80-20 rule and design notions about operating systems, the variety of different operating systems available to you, right? We'll talk more about Linux and about the Mac OS, and then we'll review what we're doing in our solution. Before we stop today, does anyone have any questions about the material we've covered?
Not right now, not for me.
Okay. Thank you for joining us. I'll go ahead and finish capturing and posting this recording in Blackboard, and we'll see you Friday.
Okay.
Yep.
Okay, have a good day.
Please get the 1.1 and 1.2 assignments done between now and then.